Good morning, everybody. How are we? It's getting better. So yes, I'm standing in for Chris today. Oops, let me turn on my clicker. Doop. There we go. I'm standing in for Chris today. He got called away to Sony because of things, network. I volunteered to give his little talk on DDoS. I have a little bit of experience with it, so I think I can speak to it fairly well. A little bit of background on us. Chris has been doing network engineering. He manages the DEF CON network. He's a trainer and a speaker. I manage the ShmooCon network. I'm a trainer and a speaker. It's very similar. We've both been down these roads several times. But the key thing that we are is, we like to do fun stuff with cool networks. And so he also happens to be running the PlayStation network. And before anybody guesses, yes, he was running the PlayStation network that day. Some of this talk was generated from the ideas and the precepts that he went through on that. So this talk is for people who run online services, people who manage 1 to 3 points of presence out on the net. So if you've got various and sundry places where you're hosting services, and you're looking between 1 and 20 gigs per second per pop. Outside of that, you're starting to get into a realm where you should be looking at vendors and hardware, but we'll talk about that. So we're going to talk a little bit about DDoS, define it a little bit so everybody has a grasp of it. Everybody here know what a DDoS? Hands. Oh, good. We're going to talk a little bit about knowing yourself, knowing your adversary, knowing the different pieces of what a DDoS means and stuff. We're going to talk about attack categories. This one's particularly interesting because of the Proton attack last week, which I've got some interesting information about. And we'll talk a little bit about defensive strategy. So what is a DDoS, right? It's an attack that intended to disrupt your service. Here's a question. Is a DDoS any different than, say, a hack attack? Yes, maybe, no. How about, are the results different if you're disabled? Maybe, maybe not, right? So it's something you should think about. Most DDoSs come from multiple sources, right? A botnet or something similar. It'll hit a critical resource, it'll knock your pipes over, maybe there are other ways to do it. State tables is a famous way to knock it over, right? Most firewalls and other routers have a certain finite limit in their state table. If you fill it up, you can cause havoc. So what's been happening? DDoSs are getting bigger and bigger and bigger. They're not going to get smaller. And most of this is because technology is getting easier and easier to implement out on the net. And people are doing dumb things. Anybody remember back in the day when you could leave an SMTP open relay? Right? That was a great way to run your mail. You didn't care. And then spam comes along, and now you're a bad guy, right? So botnets are getting very, very easy to get to by the same token. Spammers rent space on things. Now botnets, you can get them very, very easily. And you can use them to effect a DDoS, right? Anybody here not know what a botnet is? It's a bunch of compromised hosts that may or may not know it that are able to be used in an attack. So the first thing we're going to talk about is know yourself. This is the Greek for it. I'm not quite sure why Chris likes it, but okay. Know yourself. And what does that mean? So if you've seen me talk before, I talk about dealing with understanding your environment. And you have to have a core understanding of your environment, not just how many hosts you have, what their uptime is, what their load is, but maybe how they can be impacted, right? So the first question you have to look at is what traffic are you using? Do you really need all the protocols open? Do you need all protocols on your box available to the internet? Can you constrain that at your firewall, at your router, at the firewall on the host? Are there various and sundry ways to do that? Is it important to do? Does everybody need to be able to get to you? Like, right, Nick, do you need to allow all of the right subnets to be able to hit your server? Yes or no? If you don't, that's a really quick and easy way to constrain data, right? They are known for their, at least hacking attacks, the China space is. So if you were to block that at your border, or have your ISP block it, or even block it at your own firewall, you can eliminate a whole bunch of vectors very simply. And then the other part about knowing yourself is, let's say that you have an attack. What does your recovery look like? Right? If you get attacked and you get it knocked off the net, how do you recover? Do you shut down the service that was getting attacked so it's no longer a vector? Does that then impact your business such that you can't operate? Right, this is kind of what Sony went through, trying to figure out the various ways to solve that problem. Proton had an even more interesting dichotomy with that. And your business model can be impacted very easily. Anybody here been through a DDoS? Yeah, painful, isn't it? And it's in a lot of times it's completely out of your control. You feel like there's not a whole lot you can do. You can call, beg, and plead to your upstream providers to see what they can do, but sometimes there's absolutely nothing you can do until you start making plans, and that's what we're here to talk about. So again, knowing yourself, how much downtime can you absorb and still be a functioning business, right? PlayStation Network went down at Christmas. I happened to buy a PlayStation for my kids that year. It was a very unhappy Christmas morning. To deal with that little aspect. And so you really have to understand, what was the business impact to them? I would say there were a lot of Xboxes sold very shortly thereafter. And then, are there some parts of your site or infrastructure that can be down and still allow your core business model to continue? So if the web server has to go down or the mail server has to go down, does that mean that the other services can be up and still keep you viable? And when you're thinking about how to mitigate this, you're going to have to look at some of those core services and decide, okay, the HTTP server is the one that's getting banged at. Maybe I can just shut that down and leave mail up so that I can still have communications. It's a thing. You really, really have to think about it in terms of chess, right? And how many people here have been around? So we talked about spammers a minute ago. When we initially had open relays, what did we do to solve that problem? We started closing down the relays. What did the spammers do next? They found another way to get data to you using botnets, and especially in AOL, that was a very common thing. And so mail started filtering in again. So it's always a constantly, we do, then they do, we do, then they do. It's the same thing in the virus environment, right? Somebody creates a mitigation for a virus, somebody finds a way around it. It's the same thing with botnets, and we feel like that's going to continue, and it's going to get harder and harder because of things like amplification and reflection attacks. So we talked about ourselves, and you have to gather the information about yourself and figure out who you are on the net and how it works. And this applies to your security footprint, this applies to your network usage, your network load. How many people here are running something on their outside to know what their network services are, load-wise? Do you look at it every day? Yeah, one hand, two hands. You have to understand the baseline of your environment. If you suddenly see a spike, that could be indicative of, hey, maybe the fit's getting ready to hit the shan, and you need to do something to be ready. So what about this part, right? What about knowing your adversary? Is that important, yes or no?
Yes. When you can.
When you can. It's a good point. I think knowing what the attacker is thinking can be useful, but maybe not relevant to how you react, right? If the attacker is thinking, I need to knock you offline, their motivations really kind of don't matter. It's the result of what's going to happen. You're getting knocked offline. You're getting attacked. You need to find a way to solve it. Knowing the methodologies that they're going to use is very useful, because now you can start to build a defense. How many people here have a disaster recovery plan? Right? How many, does it include a DDoS? Only Monroe. So it's something to think about, because this is an actual attack vector that is starting to become more and more prevalent. And in some cases, Proton specifically, there were multiple attackers that were involved, and maybe not disassociated. So for those that don't know, ProtonMail was a company that was in Switzerland, and they did it there to be outside the legal framework of the Five Eyes or whatever. And they had a dark mail kind of service where you can send and receive mail in an encrypted environment. And they were DDoS'd for 6 days. The first part of the DDoS started banging on their service, and they were lighting up IMAP port, they're lighting up the HTTP port, and seeing what they could do to knock them down. And they took them offline. And then they said, pay a $6,000 ransom. And then ProtonMail paid the $6,000 ransom. And they were still down for 3 more days. And what happened was the attacks escalated from targeting just their network services in their network block to then attacking the ISP. And they hit the ISP's infrastructure so hard that they started taking down the other customers in the ISP. So the other customers in the ISP started pressuring the ISP, who then pressured ProtonMail to then pay the ransom. And incidentally, it had no effect. They kept getting banged on. It's interesting to me because a small company like that, you can't survive it. I'll be interested to see if they can continue to operate. Because if somebody DDoSs them again and they have a single point of presence because of their, the way they're designed, how do you solve that problem? So it becomes an interesting conundrum, right? The other piece is, how many people here defended DDoS every day? Yeah, not me. How many of the hackers do you think create DDoSs every day? They do it a lot. They do it very, very often. And they have a lot more experience in how to do it. They have a lot more experience in the different ways to impact you. Maybe they try one thing, oh, that's not working, let's go this other way. And I think that was one of the reasons that you saw the multiple attackers in ProtonMail. And then, again, can you guys sit down? How many have you done the disaster recovery drill? You sit down and you go, okay, what could happen here? We could have a biological attack. All the servers are up and nobody can touch them. We could have a fire in the building. All the servers are down and are destroyed. Where's the data going to come from, right? Have you done it could you do it with a DDoS? Could you come up with all the different vectors and ways that you could be impacted through a DDoS? I don't know. There's a lot of different vectors now. Between amplification attacks, between attacking your switching, your routing, so forth and so on. So this may be an instance where you start, based on your budget, and we'll talk about it, looking at better ways to solve the problem. And this can be multiple. It's really something you have to make a decision for yourself. So all the mitigations are largely the same, right? Do something at your border, do something with your service, do something upstream from your border. But it's going to be determined by what you know about your environment and what you can do to your environment to protect it. And it's also going to be based on budget, right? And it's really more about the highs, or the hows, not the whys, right? Why is almost going to be academic, because once it starts, it doesn't matter why. It's more about the how so that you can solve the problem. And that is what is very important. How do you know what kind of attacks are happening now? Excuse me. There are a lot of various ways, right? ISC Storm Center, that's one of my favorite. I teach it all the time. These are great vectors and places to look. Of course, our NetSec off of Reddit. You can get information there. Google News, that's where I found out about Proton long before I started getting any more technical details about it. So it's good to keep abreast of that information. So what kind of attack categories are out there? We talk about several different ways that attackers can come in, right? The network layer, your network point, and your type of source, right? So let's look at the network layer, right? HTTP is usually one of the easiest ways to bang on people, right? It's one of the more common ones. And you have various layers in here that you could attack, right? At the user application layer, you could find a way that you could cause load on the server just by beating on the HTTP port and causing enough compute time that you start slowing it down. I've been through one of those. Application layer, you could beat on HTTP itself and overrun the ability for the HTTP server to be able to serve your request effectively. Your transport layer, you can start beating on the switch, overrunning state tables. Network layer, start moving it upstream, start overrunning the pipe that you have feeding you, such that you can't sustain any more service on that pipe. Now you're not available. So there's a lot of different ways. And it really is interesting to me at how deep they can attack you. Because like with ProtonMail, I talked about a minute ago, ProtonMail, they started at the application. They started banging on the application, and they caused enough load, first on the application to knock that offline, then enough load to knock their pipe down. But when that wasn't effective into achieving their goals, their next step was to go after the border, right? And once they got the border, they not only applied enough incentive for them to make a change, pay the ransom, but they also applied enough incentive that they caused other people to talk to them and say, hey, we really need you to do this because you're now impacting us. If I were the ISPs, I would start to get more and more scared, because the more customers you have, the more concerned you're going to have to be about a risk of being DDoS'd, and based on the particular customers, right? So your ISP's infrastructure has now become a target. That's now a viable place to start banging on things. And the ProtonMail was exceeded 100 gigabits per second on the DDoS against the switch infrastructure on the connectivity back to their equipment. And that is not trivial. That is a large amount of data. There are several ways you can do it off the source, right? You could do it directly, right? You could create some processes on servers that you own or can manage and then start beating on them. You can run a botnet, right? You could do a reflection attack where you start encouraging others by setting up packets to start being that DDoS, right? NTP is famous for this one. You can do it with several other protocols. Also, like I said, you can go after the network infrastructure, go after your pipe capacity. You can deal with IP fragmentation and start overloading those buffers. SYN floods, very easy. Christmas team floods. And what's interesting is, anybody here played with Nmap? Anybody see any of those capabilities in that tool? I mean, it's there. It's not hard to actually start to construct a DDoS with the tools that we have today. And you don't have to be, you can be a script kiddie and pull this off. Doing DDoS is, to my knowledge, and I've not played with any of them, there's only a few tools that you can do for DDoS to play with it locally. But to deal with it at the botnet level, there's a lot of tools. All right, what about your application, right? We talked about HTTP. If you bang on an HTTP server enough, you can obviously start to impact the CPU or memory or I/O loads on the box and take it down. That's an easy one, right? Reflection and amplification attacks, we talked about these. This is an interesting chart that he had. I thought it was pretty cool. BAF stands for Bandwidth Amplification Factor. So each one of these is the capability to cause a packet to then reflect and cause a packet to reflect, and you have this alpha, almost like a nuclear reaction. They measure the reaction about 2 to 4 to 8 to 16, 32, 64, all the way up, and when they talk about splitting the atom, this is very, very similar. Right? You make 2 do it, then you make 4 do it, 8, 16, 32, 64, and it starts to amplify. The constraint tends to be your network capacity, your ability of the service to actually respond to that type of packet, and your ability to receive and deal with that packet. But I mean, look at the major ones. NTP is still way up there. Way up there. And so, and setting up NTP in a bad way to use for a reflection attack is not that hard. Anybody here running public NTP servers? Yeah, you might want to look at your configuration really close and make sure that that can't be done. BitTorrent, you can do a little bit. Some of the other ones, that have been around for a little while, less. SNMP v2, you better not have that public. That would be a gift, so forth and so on. So what we're also seeing is application amplification attacks, where you can constrain it not just at the network layer, but you can fire a packet to an application that then causes the application to react in a way that sends out more packets than it would expect, and not to you. You can send it to other services. So, and usually these are fun because they're injected. That's the really cool part of this. So if you man in the middle somebody, you can inject these kinds of packets to start the amplification. So people using things like pineapples or getting in the middle of a connection somewhere out on the net, it can be largely defeated by HTTPS, right? It's a lot harder to MITM HTTPS. It's not impossible, but it's surely a lot harder, and so you're raising the bar. But there was an interesting one not too long ago where an advertiser's site was compromised, and they started injecting packets into banners that they were feeding to common websites, CNN, Facebook, some of the other ones. And so that kind of an amplification attack was quite scary, because what that would do is then once the JavaScript was downloaded on your box, you would turn around and be a source for the target. And it was completely, there was no botnet, there was no hacking of your machine. It was just a very easy way to suddenly get you to start streaming packets to a target. So you have the intermediaries, right? You have ISPs that if they're attacked, they'll BGP start null routing your traffic, right? They'll black hole you. And he has some quotes here, so I'm going to give them to you. The attackers, in one of the instances he was dealing with, and this is ProtonMail, this is what they quoted. The attackers began directly attacking the infrastructure of our upstream providers and the data center itself. The coordinated assault on our ISP exceeded 100 gigabits per second, attacked not only the data center, but all the routers in Zurich, Frankfurt, and other locations where our ISP has nodes. So it wasn't just we're going to go after this one little connection that's going to ProtonMail. They went after the entire ISP to apply that pressure. That's a little scary. That's a whole different vector than a traditional DDoS, right? Traditional DDoS is done to knock them off. Now they're starting to do almost like cryptoware, right? Where we're going to knock you off until you pay us. And now they're going to do it and say, we're going to knock you off. You don't pay us. We're going to then knock your ISP off and really start impacting your business up the track. It's a whole new vector, and it's very interesting. So what is the life cycle of an attack, right? They'll start small, right? A scanner, Nmap, I can do a ping flood. Ping minus F, anybody ever done that one, right? That can be a DDoS if you do it right. If you get enough hosts to start sending those ICMPs or TCPs or whatever you're using. You start moving to ACLs and go after the network firewalls. And this is scale. This is how they move up the scale of the attack. Reflections, a terrible way or great way, depending on your point of view, of doing a DDoS, right? Because it's out of your hands. It's a self-growing problem. And then they'll go after the application, and finally, they'll go to a botnet. And botnets are easy to get, and they're very, very, very effective. So how do you defend against this? What do you do to stop a DDoS? The first thing is you have to reduce the bad traffic you receive. Start constraining your traffic. Somebody asked me the other day, should I have a public SSH server? I said, yeah, if you don't mind your logs being really, really busy all the time and you're getting banged on. What can you do to constrain it? Well, there's a couple things you could do in that particular instance. You could constrain the port to only source addresses that your associates need. So ask them for their net blocks for their ISPs. Even if it's a /16, because they DHCP into a huge space, it doesn't matter. That /16 is a lot better than a /0, right? It's a much better constrainment. And then once you start making the decision that you're actually going to do this, you have to decide, are you going to do this? Do you have the time and resources to sit down and do the research and figure out the best ways to do the mitigation? Or are you going to start looking for somebody else? And that's really going to depend on your business model and your budget, right? Both of those will be impacted. And I don't say budget just in money. Budget is resource allocation as well, resource availability. So at the network level, you can use a packet filtering device. Those are pretty easy. You can use a good firewall with a nice large stack of memory so you can have a big state table and you can do some stuff. But the packet filtering can be the bottleneck itself. Again, that state table can get overrun and then you're up the creek without a paddle. And this is what will happen. They'll just stop listening, right? The further upstream you can go, some ISPs will do ACLs for you on the border gateway coming down to you. That's a hugely great way to do this, because it's out of your hands. You've passed it up, and it'll never come on your pipe. That'll save you money, too, because DDoS can impact your pipe to the point where you'll burst, and you get charged for the burst. And they will charge you for the burst. So an easy way to do it. What else? Right, BGP null route advertisements. This is something else you can do based on source address, and it depends on the complexity of the ISP's network, but they can look at source address and then BGP null route you for those source addresses. And that's a very, very effective way, because now it's blocking it not just at that particular node, but it'll block it for other nodes that you're using the BGP share for. So IPSs, everybody know what an IPS? And intrusion prevention systems, right? They do active network defense-ish. But they can look at deep network packet inspection, right? They can look all the way down and start to determine what is a DDoS. And then you can use that information to do things, right? This one takes a lot more work. There are really cool tools like Bro, Snort, some of the other ones out there that you can use to identify it. But I'm going to go right back to the viruses, right? Everybody knows here you can use things like Metasploit to create a virus and then evolve the signature for it. How are you going to be able to identify all the possible types of DDoSs that are going to come in? I don't think I could. But this will work better than a firewall, because it's actually doing active work to ascertain what's going on. A firewall is kind of a dumb filter, right? It's going to block it or not block it. You can do, as we've done with Apple on the build network, you can constrain it by the amount of bandwidth that's in use. But realistically, that's not going to stop a DDoS. All that's doing is stopping it here, not back here where you need it. And an IPS can feed back to your ISP, and you can do work with them. So you can say, hey, I'm getting banged on this. Here's the information. They can use it to make a critical decision for you upstream. Web application firewalls, these are good, right? If you're not using them, you should be, especially if you're using PHP or running WordPress. These can do a whole ton of things. Again, bad patterns, so you're back into a pattern filter. This, for an application, though, particularly for application amplification attacks, can be useful, because you can start to, once you identify what it is, you can stop it pretty quick. So this is a good way. And if you're curious, mod security is a good one for Apache. Does anybody, I've not used Nginx that much. Anybody, is there a good one for Nginx? So the comment was you can compile up a version of mod security that will work with Nginx. Good stuff. And mod security is freebie. You can download, you can get subscriptions for it. It's a cool little tool. And you can incorporate reputation filters, and this can be tied to the reputation of the net block. So if the particular net block, say Brazil, is known for attacking, you can lower their amounts of speed and bandwidth and even access. You can drop it right off the end. The self-defense pros, if you're going to do it yourself, you're going to have a much better understanding of your own traffic because you're going to spend the time to look, right? You'll be looking at n-top graphs, you'll be looking at Zabbix, maybe Xenos, whatever you're using to collect your graphs and actually start to evaluate your network. This is a good thing, and you should have better cognizance of it. It'll always be active because you create the tools, and there's no sense in just running them when you need them. You let them run all the time. And n-top ng is a free one. If you're not using something like that on your border, I highly recommend it. It's a great little tool. And because you've spent the time to do this, when there's a mitigation, you should already have the communication paths in line to be able to talk to people to solve the problem. So you would have already talked to your networking group, your security group, maybe started organizing with your ISP. So self-defense it gives you, I think, a far better view of it. Again, it's going to be constrained by resource, time, and money. But the bad parts are, even if you do all that good self-defense on your network, they can overrun your pipe. And there's nothing you can do about that except go up to your ISP and have a conversation with them, right? This is where you start looking at a vendor solution. If you do a risk model of your environment, and you start to see that the possibility of you getting DOSed based on what you're doing, who you've pissed off, why you're doing it, starts to exceed the amount of time that you're willing to put into doing the mitigation, then you should look at a vendor. And there's a ton of them, and they're a lot easy, very, very easy to deal with. So just a quick note on stateful versus stateless. Stateful is fine as long as your tables can handle the state. Once your tables run out of state, then you're up the creek without the paddle. So you can do stateless to do some silly things like drop port 440, or only allow 443 and drop everything else. Now you haven't had to run into state tables. You just said, as a rule, drop it all. I don't care what it is. That saves you a lot of state, right? Because it doesn't have to look at the SYN, SYNAC, ACK. Oh, no, we don't want this, drop. Use stateful to control the source. So for stateful, you can start looking at the source block, and if it's coming in from Cox or it's coming in from Comcast or wherever, use that to deal with those connections so that they can complete and make sure that those connections are viable. So what are the vendor solutions that are out there, right? You have network scrubbers and you have application proxies. A network scrubber will route all the incoming traffic through the scrubber. And you can do this through a BGP announcement. You can do this through DNS announcements. There's several different ways. Can be always on or on demand, which is also useful. So the BGP can get flipped if you expect a load. So like Sony, as an example, right? At around Christmas, they probably knew they were going to get popped. This would be the time they turn it on. I used to work for a company that did cheapest textbooks online. And so at the beginning of September and the beginning of January, we always had things turned way up because we knew we were about to get slammed. Using those kind of models of your business work to influence your network work or your system work is a valuable tool. And it should be incorporated as you're working to decide how you're going to deal with things. So application proxies accept the traffic and redirect you, and they usually do it by updating DNS. And so this is, as an easy example, an application proxy would be a spam filter, right? Because you send all your email traffic to them, they process it, check for spam, and then they forward it to your mail router. Works, does a good job, does deeper level inspection. You can do a lot more with that. And again, they're always on. They're application specific. So that's the thing about a proxy. And for those that don't know, there are some proxies that can break things based on the application. If you use Exchange, for instance, and you're using the OWA functionality or the MSRPC, particularly functionality of it, that goes across port 80, and most proxies don't handle that well. Similarly, you can't really proxy HTTPS cleanly back to you. You can give them your certificate key and allow them to come to there and then send it re-encrypted to your key that's going to be on your receiving service, but now you're giving your HTTP key out to a third party. That might be a security concern, something to consider. So, what are the vendor pros, right? They can handle a whole lot more capacity than you because they're typically in border and edge data centers or core data centers, and they have a lot more connectivity to deal with. They have a 24/7 staff, so the 2 a.m. Sunday morning call, because somebody's DDoSed you, won't happen. You'll get the 8 a.m. Sunday morning email saying, hey, we had one and we took care of it. That may be valuable to you. It's valuable to me. And they're going to know the mitigations a lot better than you. They're going to be doing the research. They're going to be looking at the DDoSs that happen. They're going to be able to react to them a hell of a lot faster. Some of these will actually do consulting. So as an in-between, you can say, hey, I want to engage a consulting contract. If we get popped, we want to have 24/7, 365 access to somebody who can help us mitigate this. And that may be a good in-between, but it's something you'd have to investigate. The problem with vendors is, just as we talked about a minute ago, where an ISP can get DDoS'd the other customers on the ISP because one guy's getting beat on it, they can have the same problem, right? If somebody else gets DDoS'd and their endpoint is that space, could take you out too. Vendors are notoriously tight with their customer lists. So this is an interesting problem because some of the risk that you will decide to accept is based on an unknown, right? Let's say that I was going to go into a data center for Switzerland. For those that don't know, I used to work for Blackphone. That's where we had our data center. And I put it in that data center. What if my business systems had been right next to Protons in the data center? We'd have gotten knocked offline. Would I have known it, that that was a risk? No. How do you deal with that? I don't know that anybody has an answer to that problem yet. The big one is you don't have to deal with your carriers. So you don't have to deal with level 3, you don't have to deal with AT&T, you don't have to deal with all those guys to get your BGP announcements changed, to get other things dealt with. So this is a big help because normally those lines of communication, A, don't happen well, and B, it's hard to actually influence them to the point where they will make a decision. If these guys already have those relationships in place, they can help you mitigate those problems by having those relationships, having those discussions, say, no, this is a real problem and we know because we do this every day and he's having an attack that really needs to be mitigated through a black hole or a redirect or whatever. Yes, sir. Use the mic, please. I'm sorry.
So in a situation like this where you're going to a vendor, how would you handle something that needs to be application or where your service or application is latency critical? Wouldn't going to a vendor introduce another hop?
Yes.
And added latency?
Yes, and so when I worked at Blackphone, that is exactly the problem that I had, is that we were a VoIP service, right? Latency is a big deal for us. So you have to look at your business model to see if this is viable. A proxy may not be a good solution for you, right? Because that's going to add latency to the problem. A redirect, maybe, depends on where you are in relationship to them. The other problem we particularly had is you have peering agreements that you have with other VoIP services that you want those as close to your POPs as you can get them, right? So that your relays become real short, and because you got to get it down below, I think we said 120 milliseconds before it really becomes so noticeable the customer starts throwing yellow flags. So it is an issue. It's something you have to evaluate in your model and see if it would work or not. Usually it's the interactive things, right?
Yeah, so what would be the workaround then if a vendor solution isn't there and you can't
Well,
have
so
added
if
latency?
the workaround at that point is have the vendor work with you at your site. So now instead of offloading it out to their big, huge data center where they're routing the traffic through and dealing with it, you have the routed traffic and then they help you with on-site tools to be able to deal with the problem. And you can do that through firewalls, you can do it with hardware, there's lots of things. In other words, the BGP work and all that stuff that would be done through the rerouting at the core, move that back to your edge. And now you have some things. And the other thing is, of course, get a bigger pipe to them, right? Yeah. That may be a solution. Good question, thank you. And to that point, what are some of the vendor gotchas, right? What is the mitigation going to do to your normal traffic? Just exactly what you said, right? How are you going to deal with it? Most answers are based around web traffic, which is more or less stateless. Right? There's an expectation of I think we had a 7-second response for a book search. That was a requirement, and we dealt around that. And in that context, that's very easy to do. But native phone apps, yeah, they don't like that. That's a bad, bad thing. And Internet of Things, I think, is going to add more and more of that type of problem because it's a much more interactive service, right? People that are, I'm going to start my car, bump, and it takes, 10 seconds for the car to start, they're not going to like that. They're going to think it's an invaluable service to them. So, but the connection back to you is one of the biggest parts, right? And that's the other part I just mentioned, is make sure that you have enough pipe to be able to deal with what you're going to accept. And make sure that it's maybe more than one provider if you can afford it and spread it through your BGP announcements. So These are also things, how hidden are you really? Is this pipe a direct pipe that only goes between your provider and you and nobody else can feed traffic over it? Is there another pipe that you have available if you do get DDoS'd, right? If you're a monolithic company and you're within an office building and you get DDoS'd, how are you going to get out to research, contact, do anything? You might want to start thinking about an out-of-band communication method that would allow you to continue to operate at some level, right? There are different ways you can encumber that. You might start looking at the different applications you have and separating them by scope into places that will be least riskful to your business. So maybe your HTTP service that you're providing, put that off in the expensive place that's getting all the protection, but leave your email and this, that, and the other in blocks that are hidden and not visible to the attackers so that you can continue to function. These are things to think about. When you're looking at a vendor, right, your capacity is a key point. And to know that capacity, you're going to have to do some research on your own stuff. You're going to have to know what you can deal with, what you expect to burst to, and then you want to add, I don't know, 10, 20, 30, 40% over that to make sure that that guy can handle it for now and the next 2 to 4 years or however long that you're doing your case study. You want to make sure their points of presence are close to you, right? We just talked about that with relation to VoIP stuff. So if your POP is real close to them, then the latency between these two will be minimal. Therefore, you can insert them into the process and it doesn't impact your core application. That's important. You want to know how they're scrubbing. That could be useful to know. You want to have some idea of what they're doing and why they're doing it so that when you're troubleshooting problems, you can understand that vector and understand what impacts you may be having just from that service, right? Again, you want to understand their configuration, how they're set up, what their incident plan is, how transparent they are to you about what they're doing. If they say, oh, we've got it, and turn around and walk away, are you going to feel comfortable? Are you going to be able to report that to your management structure and say, no, they've got it? Well, how do you know? Because they told me. These are important things to understand, right? And then your different ways to connect, right? You can do it through a GRA, you can do it through a cross-connect. There's all kinds of different ways to get connectivity between you. If you can find somebody that can mitigate in your core data center that's already there, that's a huge win-win-win. Assuming, now back to ProtonMail, the data center could survive an attack that you might take. And I don't think ProtonMail expected they'd ever get a 100 gigabit per second attack. And that level of attack, if you go read, they stood up a blog site that was off of WordPress, I think. It was a separate one. But they talked in detail about what happened. And they're starting to think the second phase was state actors because the level of attack was just extremely sophisticated. I don't know, but that's their thinking. And then pricing model, right? Do you have the money to do this? Is this something you can do? Do you have per port fees? Do you have per bandwidth fees? Is it incoming or just cleaning the traffic that's coming in and going out? So here's some vendors that do this. Most people know about A10. Most people know about F5. AWS, obviously they've had Route 53 around for a long time. They've had a couple of the other proxy services that they've had. They're very effective. They work very well. And they're not too unreasonably expensive. Those are the ones I can speak to because I've actually put hands on them and do them. Cloudflare, part of Amazon. Anybody else have any other recommendations for those that have dealt with DDoS? Any other recommendations for servers or services that you've used? Fastly. Who? Fastly? Fastly, says Alice. Anybody else?
Also Black Lotus and
Staminus and Black Lotus. Those are two others. So if you're looking for vendors, these slides will be put out and Chris will make them available. You'll definitely want to start looking at them and then write those down if you're interested. So which path are you going to take? What is your decision process? What are you going to do? It really is going to depend on whether you have time for the cat and mouse and figuring out how to defeat an attack that may come in or not, right? It's going to depend on your application. How much can it survive? How much can your business model survive? And then the whole system, right? Is there maybe ways you can start to scope and move parts of your system apart from the high risk to low risk so that you can continue to do things in an operative manner? It's up to you. Just some parting shots, and these are things that he put up because he thought they were important, and I agree with this one. Amplification attacks are starting to become the biggest threat right now. Because again, once you kick them off, you can step away and just watch the hell that follows. don't be part of the problem, right? Don't run an open NTP server because I can then use you. If you have any large public DNS records that are available via UDP, that's the easy way to go. Most people shouldn't. If you're running you should not be able to see your inside network from your outside DNS server. If you can, you might want to rethink that. And then are you watching your traffic? Are you really spending the time? NTOP NGs, freebie, go download it, install it, set it up on a span port, and you will get a large view. If anybody wants to see, I'll be down in the lab or down in build later, and I will be happy to show you the one that we have set up down there with all the details of what's going on here. So I think I have about 5 minutes for Q&A, 4 minutes from Q&A. Does anybody have any questions? Get a mic, Monroe.
So on a network level DDoS event,
Yep.
it's all reactionary. You have to wait for it to happen in order to do something to stop it.
It's better than that. At what level do you consider it's actually happening?
Right,
When
well-
do you know?
Well, that gets to my question of, it's also very difficult to simulate. So I'm looking for, and haven't been able to find, some kind of crowdsourced resources to help test our processes and thought processes.
Rent a botnet? I mean, that's what all joking aside,
But it seems like these happen a lot to a lot of people, so the information is already out there, and to test my workflow against history would be helpful.
yeah.
And
My
don't know.
understanding is, I've talked to some of the security companies, and this vector is becoming one that's now going to be that they're starting to evolve into a testing scheme. So if you have a yearly or more requirement for incident testing or security penetration testing or anything else, ask them to add this to it. Ask them to say, hey, what would it take for you to do a DDoS on us that would be safe within the context of your business, and start to understand. Or fake it and have them watch you as you go through your processes and catalog and identify issues you may have. This goes back to the vendor thing, right? That's really where a vendor's going to have a hell of a lot more experience in how to walk through that process and deal with it. And if you are going to engage them, you should ask them to sit down and do exactly that.
But they want money.
Of course they want money. Again, if you're looking for a self-signed solution for that kind of thing, what I would do is set up I would do it in a lab network as best you could.
Well, no, what I'm looking for, I'm wondering if there's an online resource of people who have been through this and share their experience so that I can apply our solution to their analysis to see if there are holes.
I'm not aware. So the DDoSs that I went through were, we did not have access to resources. We didn't know about those resources. We ended up calling, in one case particularly, we ended up calling a vendor because it was outside the scope of anything we thought we could come out and solve in a short enough period that it would have helped the business not be so impacted. That was the key, right? It became a business decision, not a technical evaluation decision. And that's the sad part, is it happens rapidly. You start seeing an upswing in problem, and you think, well, maybe it's nothing, and by the time you decide it's something, it's way too late to stop it. So we had that happen, and we went through that stupid exercise, and by the time it popped our pipe, we were on the phone starting to look for somebody and called somebody. Please.
A suggestion then is call the vendors and say, how do we figure this out? Do you have any customers you can talk to? Do you have like a salesperson who's done this for other customers?
Now that's a thought. Vendor references, you could use that. Hey, can I get a reference for your company? And somebody that you've done a lot of work with, and then when you get the reference, say, okay, what'd you do and how'd you do it? I mean, that's one way you could social engineer it. Peter?
I didn't see it in the slides, but one thing I always do, since we have a lot of web stuff, is to have a graceful degradation. So I know when I get the DDoS attack, it fails in a controlled space. So if I have a web application, I don't get like trashy data or break my application or a subsystem. So it breaks in the edge in the load balancer. So the load balancers is where it breaks instead of further down the stack in the application.
Sure.
Preferably.
Sure. Well, so you start asking the question, especially because we're in this cloud environment, right? If it breaks at the load balancer, you've probably saved the associated processes that were running on the VM servers that were near where your application servers were in the first place. Because if you start overloading all your application servers on a VM environment, you better have segregated things really, really well, because you're going to have impacts. Even VMware, with the things you can do to scope it, you're still going to have problems. And then you start doing the thing of, okay, what can I shut down so that I can try to survive this? And that's a bad, bad place to be. So this is where the planning comes into play. I think it's kind of a dual, I think it's a dual thing. I think if you look at the risk of this and you think it's a reality, you think this is going to happen to you, you really should just sit down, do a tabletop discussion, and start making some associated plans. And the end game of that may be, okay, we're going to go up to this point, and after this, we're going to get a vendor involved. And this point may be setting up our network. This point may be distributing the system, all the different ways that you can do to try to solve this problem. But you need to make that decision, and you don't want to make it under duress. That is what I think Chris's biggest point to this is. Spend some time to do the planning and figure out where you want to be when it happens, so that when it does happen, you have that plan in place and you're not pulling your hair out and looking like me trying to solve the problem. So I believe I am out of time. If anybody else has any further questions, you can catch me here or down in Build. Thanks to Chris for allowing me to do this, and thanks to you for listening. Have a great day.